Welcome to Advent of Code Day 6, which is called Guard Gallivant. I don't know if I spelled that correctly, but let's roll with it. So, the historians use their fancy device again, this time to whisk you all the way to the North Pole prototype suit manufacturing lab, in the year 1518. It turns out that having direct access to history is very convenient for a group of historians. You still have to be careful of time paradoxes, and so it will be important to avoid anyone from the 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so that the historians can search safely. You start by making a map of the situation, which looks like this. And then I already pre-read this, and it's basically, so here's our guard, it's looking up and it goes up until he hits an obstacle denoted by the hash. Then he turns to the right for 90 degrees and goes to the right and hits another obstacle and goes down until it hits this obstacle, goes here until it hits obstacle, here, 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 and then it comes to the end of the grid. And that's where our search ends. And what we have to do is mark where the guard has moved, and when he reaches the edge of the grid, we have to count how many places he visited, how many distinct places he visited. So yeah, that's the puzzle. Let's go and try to solve it. So I've already got my inputs, already did the reading. So if we check, we can see we already have the test input in here, and now we can start coding with part 1. So basically we have to find where the guard is and where he's looking, and then just, go in the direction. Now I want to check, is the guard always looking up? I don't know if I'm gonna find him here. Let's assume he's always looking up, so we don't have to write any additional boilerplate code. So yeah, we just have to find him. I think I figured out how I could. If I copy, find, paste. He's here, and he's looking up. So yeah, he's always looking up. So we just have to find it. So yeah, let's find the guard first. Well, we're just gonna loop through. We're gonna need the index and the row, I guess, of range grid. And then for each element of the row, range row, we check if the element is equal to this thing, which I have in my clipboard. Like that. And we have the position. So let's do guard. Let's do I. No, let's do guard I equals 0 and guard J equals 0. And then we just set these two values like that, and also break. So now we have the guard values. What's wrong with you? Declared and not used. I don't think so. It is used. So we have found the guard. Now I want to make an enum for the directions. I don't know how to do that in Go. let's see, enums. Right, so supposedly you just do cons. So first you write type, let's do the direction. It's gonna be an int value, I guess. Doesn't really matter. And then we do up direction equals iota. And then we've got right, right, down, and left. Okay. So let's guard the direction equals up. Okay, so now we've set the guard and now we can walk the guard. So I think I'm just gonna make a function for this. Move guard, which is gonna take a grid. Grid is a list of strings. And then we're gonna take current type, current position, and the direction, like that. And now we define next I, next j. Both of those are going to be integers. And then we check if dir equals, can I do it like that, up? Or maybe I can do a switch actually. Switch dir. How do I do that in Go? Like that, I guess. Dir, case, up. Okay, case up. And what do we have to do? If we're going up, we do I minus 1, right? Oh, we need equal sign. And break. Do we need the break in Go? Go switch. No, we don't need the break. That's pretty nice. We just do it like that. We go right, which means we do next j equals j plus 1. Oopsie. J plus 1. And then case down, we do next I plus 1. And case left, we do next j minus 1. All right, and I forgot the equal sign. So now we know where we're going, and this function is gonna actually return, let's do it the go way. So it's gonna return 2 integers, which is the new position, and the boolean, which is gonna be an error variable. So if next I is less than 0, or next j is less than 0, or next I is bigger or equal to length of the grid. Oopsie. Having some trouble with this keyboard, right? Or next j is more than or equal to length of the grid 0. In that case, we return nil, return nil, nil, and false. We can't return nil. Can we do that? Probably not. What does it say? Cannot use as value of or time. All right, let's just do -1 then. All right, so we have a valid position. Now, if at the next position next j, we have the hash. Oopsie. No, I don't want those. I want single quotes. Yeah. If it's a hash, then we just have to switch direction, but I'm not sure. Can I do it like dir plus plus? Yeah, I can do that. All right. So let's do it like that. So there is dir plus 1 plus 1. Let's do it the simple way. Dir plus 1 if dir is n or equal to 4, dir equals 0, which is equivalent to up. Because up is the first one defined and iota is, I guess, 0. Yeah, it's 0. Okay. So if we do that, we just rotate him. And I guess that's it. One thing we have to do, no, we don't have to. So we do that and we return, we also need to return a new direction. Almost forgot. Let's do -1, -1, -1 then. And then we return next I, next j, dir, and false because there was no error. Right? And else we just return next I, next j, dir, and false. Now we can simplify this by just actually removing this else and removing this as well. Let's do it the Vim way. dd. Yeah, all right. Okay. So this is movement. And what we're gonna do now is while, so for, I'm not sure if I can do that, for next move guard, we put in the grid, guard I, guard J, direction, which is the guard direction, and we do that guard I, guard J, guard direction, and error equals that. And now we put this, and now we can make a statement, right? Or a condition. So not error, I guess. And while this, so this is basically an infinite loop, but what I want to do is grid, I have to mark the position. So guard, no, grid, okay, guard I and guard J equals X, okay. And also I have to do that here before because this is basically a do while, but Go does not have a do while, I think. It only has for, so this for, right? And yeah, unexpected new line. What? So this is not gonna work. So let's try googling Go do while, I guess. So I think I need this. No. So initial value condition. Oh, it's all right. So error equals false, and then while not error, we do that, and we remove that. Oh my god, we got more problems now. So like that. What was happening with autocomplete here? Okay, and what's the problem here? Cannot assign to grid neither addressable or a map. So this is a list of strings. Why it's not addressable? We can do a workaround. Oh, Go does not have a set. Check how I would do that. Cannot assign to grid. Why not? So what if I would do that? Let's try it. No, this would work, it seems. What if we put a comma here and guard J? Invalid operation, okay. So Go mutate string. We're having a problem with mutating strings. So we have to convert it to a rune, it seems. What's a rune? Rune is an alias for int32. Okay. This is weird. So there's a function replace which you can use, I guess. Not sure if that's the best option, but strings, not replace. Okay. So shit, this is getting a bit weird. So we do guard I equals to strings replace grid guard I. I'm gonna replace this with X. No, we're gonna replace a dot with an X at the index of J. This looks weird as hell, but let's pretend it's gonna work for now. All right, and that should be it. There's no errors. And now, so I just comment a bit, move the to failure, and this. I guess we just loop through everything. And first we need a sum. Mm. Ah, shit. And again, we do this element for the range of the row, and we just if element is equal to x, we increase the sum by 1, and then we just print the sum. All right, so this is it for now. I hope there's no errors. There probably are, but yeah. Index out of range, where 94. Oh yeah, no, it's fine. How can it be out of range? -1, -1. Yeah, but if it's -1, why are we getting in here? Okay, this is a bit weird. Mess this up. Yeah, I messed this up, true. We have an error. All right, yeah. This is much better. But the direction is not getting updated, I think. So if it's a hash, we increase the direction. Let's do string. Let's see if we even get in here. No, we're not getting in here. Why not? So we have 6, 4, 5. What? Maybe we do need a break here. But the example I looked at didn't have them, so No? Yeah, we don't need them. Oh, of course. What am I doing? So this is I and J. Yeah, okay. Now we're looking much better. Although I don't think that's the right answer. It should be 41. But what we can do is we can print every row here and see where we mess up. Okay, that doesn't really look right. Oh, this one is not getting replaced. Why not? Oh, because it's the, yeah, okay, I see. I have to copy this fella. I don't know if this worked. Yeah, it worked, okay. 34, all right. I think I messed up the directions. So we're going to the left for some reason. So the guard direction is up. And so we should be going up, right? Let's do it like that. So this should be up. Yeah, it's up. So 6, 4, 5, 4. Yeah, that looks correct, but I don't know why it's not reflected in here. So 6, 4. Let's check here. So 6 and 0, 1, 2, 3, 4. Yeah, that's correct, right? 6, 4 false. Okay. And then we go up, which is 5, 4. Yeah. And we go up, which is 4, 4. I think it works fine. And the axes are just not placed correctly. By printing the grid of card I guess. Oh yeah, this is completely not correct. Oh my god. I'm just gonna copy some function from Stack Overflow. Replace at index. Okay, out of I equals R. Right, let's try using this. So we get rid of this and we just replace that index. All right, now it's better. And we have another problem. So we get up to 0 and 4. But we shouldn't get up to 0. Yeah, we have to backstep basically. Right, this is a bit inconvenient right now. How should we do that? Oh yeah, we just do next I, next j equal to I and j. That's the solution. And now we have the correct answer. So we can remove all of this. Remove this. We also don't need that, I think. Yeah, that's fine. And we also need to print the initial grid. And we can comment this out as well. So now we have 41, which is correct. And now we put in my input. And we get something else. Let's see. So that's the right answer. We got 1 gold star. Let's see what's part 2. While the historians begin working around the guard's patrol route, you borrow their fancy device and step outside the lab. From the safety of a supply closet, you time travel through the last few months and record the nightly status of the lab's guard post on the walls of the closet. Okay. Returning after what seems like only a few seconds to the historians, they explain that the guard's patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause the time paradox. They would like to place the new obstruction in such a way that the guard will get stuck in a loop, making the rest of the lab safe to search. To have the lowest chance of creating a time paradox, the historians would like to know all of the possible positions for such an obstruction. The new obstruction can be placed at the guard's starting position. The guard is there right now and would notice. In the above example, there are only 6 different positions where a new obstruction would cause a guard to get stuck in a loop. The diagrams of these 6 situations use a circle to mark the new obstruction. And the vertical line to show a position where the guard moves up down, minus to show a position where the guard moves left right. Okay. So let's see. Oh, so we can place one here, okay. Okay, so these are all the options. It doesn't really matter what you choose to use as an obstacle so long as you and the historians can put it in position without the guard noticing. The important thing is having enough options that you can find one that minimizes time paradoxes, and in this example there are 6 different positions you could choose. You need to get the guard stuck in a loop by adding a single new obstruction. How many different positions could you choose for this obstruction? Okay, so basically what we can do is try placing an obstruction on all the axes and testing if the guard is stuck in a loop. So yeah, let's try that, I guess. Yeah, utilize this. And we need I and we need J, and we do replace at index grid of I. We replace it with the hash and add position J. So now we have grid of I go to this, and now we have to test, and then we replace it back. So actually we can just do temp grid of I. Probably we'll see if that works. And if I equals temporary test and sub back. Now we have to test. How do we test? We'll have to we'll basically have to remember all the positions, I guess. I guess we use that. So we have function test. Test. Yeah, test is just fine. Grid string. We're gonna need a starting position. And we're gonna need anything else? I don't think so. And return a boolean. Okay, so now we have to define like a list. Maybe I should make a new type for this. So how do we make types? Let's make a type. Type. Type position, I guess, which is gonna contain I, is gonna be an int, j, which is gonna be an int as well, and there is gonna be a direction. Okay. And now we need a variable var memo, I guess, which is gonna be a struct of positions. And I'm gonna just make a contains function. Turn false. Now for each position in the memo, we have to check if pos.dir is equal to x.dir and pos.i equal to x.i and pos.j equal to x.j. So that's equal, return true, otherwise return false. All right. So we have this. We have to do basically just move the guard. Oh, what happened? We don't need to do access now. Gonna do that. Memo equals to append memo, and I'm not sure how to initialize the struct. How do we do that? Let's see. All right, I think I found it. So you have to do position. Okay. Can I just do guard I, guard J, and direction? Can I just do it like that? Seems like. Be right back. Okay, I'm back. I had a phone call, sorry. So yeah, I completed the test function and now you just have to call it. And if the test is successful, uh, it's out and complete, it's getting weird. So if the test is not successful, we increase the sum. And that's it, I think. So let's just print the sum. And that should work. So if the test is not successful, we just increase the sum, revert the changes, and that's it, probably. Let's take out the test. And we got 41. Okay. Why do we get 41? Did I put in the, yeah, hash on grid J? And if the memo contains the position, we append it. I mean, if it contains the position, we return false because that means it was already visited. Yeah, that seems correct. Let's just try. Can I do it like that? Yeah. Thanks. It seems like nothing is happening. Why is that? Was the file saved? Yeah. So, oh, let me just check. Maybe it fails immediately for some reason because I input the wrong parameters. So error is false. We do it until the error is true. Guard I, J, and guard direction. We read it from here. We put in the grid guard I, guard direction. So yeah, that seems really weird. Oh no, we're getting in here. Oh, it's actually working, kind of. But the problem is, it seems like it always contains, even though it's empty. If memo is nil, return false. I mean, no. I mean, that's the default, isn't it? Oh, we're appending something here. And then, I mean, oh, it's the, yeah, I don't know why I did that. Of course. 6, yeah, it's working now. Okay, delete that. Ah, we can just delete this. Move guard until failure. Uh, memorize the visited location with respect to direction. Okay, so now if I do that, we're getting a clean 6. And where is the 6? Yeah, there are 6 different positions you could choose from. Now let's try my input. Yeah, this is taking too long. All right. Oh, we got some we got some result. Let's see. Oh, that's the right answer. We had to wait a bit. But yeah, we got the right answer and earned 1 gold star, which makes our total 12. Right, pretty nice. Does it? Yeah, it saves my. I might actually optimize this a bit. So what I'm thinking is we could optimize by, so wherever we change the X to an obstacle, we could start from the neighboring field and not go from the initial starting position of the guard, which I think it would drastically cut the processing time. But we would need to remember each position even in part 1 by doing that. So it's a bit more complicated to implement this, I think. It's not much lines of code, but I think I need to think about it a bit more. But yeah, we got the correct result in kind of okayish time. It's not the best, but it works. So yeah, I think that's all for today. I'm just gonna uh, write a quick my quick impressions. It was pretty easy overall. I liked it a lot actually. Took a bit more time in today's part. 2 took a while to compute, um, like 5+ seconds, but the answer was correct. Both part 1 and part 2 were first try, not counting syntax errors and typos. Do I need to add anything else? Yeah, maybe I could optimize this a bit by optimize part 2 a bit by starting just for by starting the test just 1 move for and countering the new obstacle, the new laced obstacle. Obstacle. But I say the position struct when doing part 1. Okay, I think that's it. Okay, looks fine. Oopsie. This was day 6, right? And let's push. Okay, that's it. Thanks for sticking around, and